In this video we're going to look at how to find the sum of an arithmetic series. So in this first question we're asked to find the first 20 terms for a series which begins 5 plus 7 plus 9 plus 11. So I'm going to start by writing down the formula for the nth term. And I'm going to find the values that I need here. So I need the start term, so this is where a is 5. I need the common difference, which is 2, and I need the value of n, so it's first 20 terms, so n is 20. So then S20 is equal to 20 over 2, multiplied by 2 lots of 5, added to 20 subtract 1, multiplied by 2. So I'm going to simplify that. So 20 over 2 is 10. 2 lots of 5 is 10. Add 19 times 2, which is 10 lots of 10 plus 38, which is 10 lots of 48, which is therefore 480. In this second question, I have it in a context, so find the time required to exceed £100 if £1 is earned of day 1 and £1 extra is earned each day. So I want to find where Sn exceeds 100. So when the sum of the terms exceeds 100, that's when I know that this has been met, and I want to find the value of n because that's the number of days that will be required. So we know Sn can be written as a formula, so I'm looking for when n over 2 lots of 2a plus n minus 1d exceeds 100. So a is 1 and d is 1 because it's £1 on the first day and each additional day is an extra £1. So n over 2 lots of 2 lots of 1, add n minus 1 lots of 1 exceeds 100. So n over 2 lots of 2 plus n minus 1 is greater than 100. So I'm actually going to multiply both sides by 2 now, get rid of this fraction, and I'm also going to simplify the brackets slightly, so 2 minus 1 can become 1. And then I'm going to expand the bracket, so I've got now n plus n squared is greater than 200. So n squared plus n minus 200 is greater than 0. So I can now look about solving this using what I know of quadratics, and it's unlikely this is going to simplify, going to factorise, because I don't think I'm going to find two numbers that have a product of 200 or negative 200 and a difference of 1, because that would have to be close to the square root of 200, and I'm not going to get what I want. So what I'm going to do is I'm going to do this by a little bit of trial and error. So I'm going to look at just n squared plus n, and I'm going to try and see what values would get me close to 200. So I'm going to start with 13 because I think that's going to be pretty close. So when n equals 13, n squared plus n minus 200 is 169. Add 13, subtract 200, which is negative 18. When n equals 14, n squared plus n subtract 200, so 14 squared is 196, add 14, subtract 200, and that gives me 10. Now if I look back to my inequality, I wanted to know where it exceeds 0 if I write it in this form. So when n is 13, it did not exceed 0, when n is 14, it did. So 14 days is the time required in the context of the question